Well, let's write u is cos x, okay? And du will be negative sine x dx. So negative sign will cancel with this sign and leave the negative signs, right? And we have now integrations. 1 and we have this integration. And don't forget the u, x 0, u is 1, and x is what? 5/2. U will be 0. So we start from step 1 to 0. Okay, now we have this. Then what is 1 plus 1 plus u squared du integrations? Who said that? Oh, yeah. Tangent inverse. Yeah, inverse of tangent, right? Because you have 1 plus x squared usually, right? In your tangent inverse. So we can write this just we write negative tangent inverse 0 minus tangent inverse 1. This 0, right? This is 0, and minus positive. So it becomes tangent inverse 1. What is tangent inverse 1? Yeah, p over 4. Okay? Okay. Got the idea? So learning integrations, you cannot separate from derivative because they have connections. So you need to at least some basic derivatives and some necessary derivatives. You need to familiar with them. Okay. At least if you forget how to integrate, you still remember how to derive, and that is how to prove all the answers in integrations. Okay. Okay. Any questions? Okay. So pretty much the integrations based on what we have done in these two examples. Whenever you have the integrations look similar, but how you solve maybe will be really different because you make a little change like 1 plus cos, okay, and then the other one plus cos squared. It's different for the substitutions. Okay, so you need to choose wisely and to think more deeply, okay, and how to connect the integrations to derivative. Okay. Okay. Okay, we have done two examples. Okay, now we have number 3. I think for number 3, the first one here, it's quite simple, right? It's not too complicated. You have x, and you see the inside of the the square root is x squared minus 1. Okay. If you derive the x squared, it will be 2x, and it will cancel the x, right? And you can get the answer easily. And you can get the plus 1, right? 3 over 2, 3 over 3. Yeah, yeah, not too complicated. Now, what about this one? X and then square root of x minus 1. Okay, any idea? Okay. Okay, any idea how to solve it? Let me give you a couple of minutes to think. Whenever you have the answer, try to derive. If it's going to original, then that's okay. Okay, this is quite tricky. Okay, quite tricky. Let me write the substitutions. Okay. Okay, let me write the u for this integration is x minus 1. Okay, let me write this first. Du will be just dx, right? So if I have the integrations x and then u and then du, I'm still having this x, right? Now look back at this u. X is u, yes, then we can substitute. Oh wait, it should be square. And then we can to yeah, and then we can integrate each element. Use 3/2 half. It's 5/2, so 2/5. And then it should be x minus 1, 5/2. And plus 2/3, x minus 1, 3/2, plus constant. Okay, so that tricks you can do also. Okay, if whenever you have used substitution and you want uh, to take back the x, and you can switch. You can switch u and x. Okay, any questions? Okay. Uh, okay, let me give you another example. Hmm. Okay, let me give you this one, x cubed plus x. Okay, I'll give you, let me give you 5 to 7 minutes to think. At least it has, uh, in my experience, have two methods to solve. The first method is actually using substitution. You need to do some tricks in the equations and then use the substitutions. And the other method is, if you know, it's called using partial fractions. Hasilnya mana? Udah, nggak bisa berarti salah. Oh, good, good, good. Hmm?
Belum.
So I think this one should be bx plus c. This one should be bx plus c because it's x squared. Okay. But the idea is okay. Hmm? Kira-kira apa? Angkanya nggak ada di situ. No. You can check whenever you have the answer. Try to derive. If this derivative is, then that's okay. Is it the same? No. No, right? Any idea? No. Any idea? No. This is it the same? 1 over x plus x, but you have 3x squared plus 1. But you have the chain rule, right? So what's the answer? Do you think? The answer we will have the ln. The answer will have ln. Any idea how? No? Okay. Okay. So first method, okay, using substitutions. Okay. First, whenever you see any functions like this, you need to rewrite the functions first. Okay. Let me write the integration. 1. Okay. Let me factorize. You have x cubed and x. The biggest one is x cubed, right? Let's factorize the x cubed. It's become 1 plus x, right? Oh, let me make bigger. Okay. Now, okay, this x cubed I can move to here. Is that okay? X cubed, this become x minus 3, right? Let me write x minus 3 if this is the functions. Can you substitute? If you have, if your functions x minus 2, what is your first derivative? It's become 3, right? Minus 3. It will cancel this, right? So you can substitute. But you need to rewrite the form. So let me write the u directly. So let me write the u will be 1 plus x minus 2. And du will be minus 2x minus 3 dx. So it becomes negative half, and then 1 over e d, and it will be ln of the 1 plus 1 squared. Okay, so you can do things like this case. So this is some notes for any negative power. Okay. Yeah, let you think about this first. Okay. Okay. I will give you time to breathe. So sometimes this is a preferable solution. It's directly getting the answer. Right? Some textbook for this case usually just using the partial fraction. Uh, Partial fractions is you have the okay, you have the x cubed plus x. Okay, rather using the x cubed, you can factorize just x. Okay. Let me write also here. Okay, and the idea for partial fractions is we need to separate the denominator. It becomes to separate fractions. Okay. So it's x, and the other one is x squared plus 1. And how to know the numerator up here? Let's just find. Okay, we can write just constant a here. Okay. And the other one, yeah, because it's squared, this should be line equation or linear, right? Because it's quadratic, this should be linear. So bx plus c. And then we need to find our a, b, and c. Okay. And how to find? See this, the big denominator here. This is the result if you are multiply this, right? Okay. So this divided by x multiplied by a, right? Got it? So a 1 plus x squared Let me make plus this divided by this multiplied by this, right? And plus x bx plus c, it should be equal to 1, right? Okay. Now we just solve it, find a, b, c now. So a plus ax squared plus bx squared plus cx equal 1. Okay. Is there any x in here? No, right? So a will be 1, a plus b 0, c 0. Or let me write one by one. So a plus so a is 1, a plus b is 0, so b is negative 1, and c is 0. So the integrations become, oh, I forgot to make the integration here. So the integration become 1 over x, okay, minus x over x squared plus 1 dx. And this will be ln x. The right side is, we need to use some substitutions, right? X squared, x to x, right? So let me write here 1 over u du, but it's actually 1/2. So it will be negative half ln 1 plus x squared, right? And before that, you can check first, okay? When you multiply or when you compute these, it should be returned to original equations, okay? Um, let me write this. Okay, same. Okay, so you can choose left method or right method using the partial fractions or substitutions. Okay. Maybe I need to give you more details here. Okay. So whenever you have um, fractions in integrations, okay, this is usually the general solutions. Okay. If you can separate this denominator, if you can separate, becomes two fractions, and usually it's having simple equation on the top. But if it's having like x squared, then you need to just plus with that equation and make the um, solution here. Okay. But because it's only one, then the other part, the x squared and x is 0. Okay. Okay. Um, we will go back again in this session, the partial fractions later. Okay. I will give you more details example, but this is how you solve it. Okay. If you have fractions. Okay. But you can also, because it's having only 1 over and then the whole x cubed plus x, then my suggestion is, you see here, these functions, uh, you can just substitute and rewrite the x cubed factorize and make the x minus 3 and x minus 2. And this is having relations, right? Because they are the differentiable, okay? And make use substitutions, and you get this ln blah blah blah. Okay? And then I think this one um, is actually not too bad, right? It's still doable, and if you don't have uh, idea to factorize like the substitution, I think this is better. This is better. Mostly in fractions, you can separate the fractions. Okay, become maybe 1, maybe 2, maybe 3, and you can integrate each one. Okay, you can integrate each one. Okay, let me give you 1 or 2 examples. Okay. Okay, I think all the examples for you some I will upload the notes, only the example, not whole notes. Okay. So you can focus on the how to solve. Okay. Okay. Let me give you questions. Okay. If f is continuous on oh wait, it's just and okay. So f is continuous and this is equal 6. The question is 0 to pi over 2 f. Okay. So whenever you see this type of questions, it's like exam 5, right? Okay, let me give you several minutes to think and solve. If you solve it, if you get the answer, raise your hand. Okay? I want to know how. Wait, I forgot. Too easy, right? Too easy. Which one? Which one? Mm-hmm. Mm-hmm. This one, right? Yeah. Okay. You get the answer? No? Yeah. You can continue. Mm-hmm. Wait, what is this? X squared minus
No,
1?
the second one.
Okay. Yes, yes, yes.
Like
Uh,
it's different from
it's
yours.
2x.
Yeah, like when we derive it, it will use the product rules.
Uh-huh.
So we will have this one and 2/3 of x minus 1, 3/2.
Mhm.
And minus this one when we derive it and we can cancel out that factor.
Mm-hmm.
So it will be this one.
Yeah, 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 yeah. Yeah, yeah.
It's different from yours.
Really?
Yeah,
What is mine?
yours and this one
Maybe I
is
forgot to multiply this. Yeah.
yeah maybe and this one is
Okay, okay.
2/5 or
Mm.
15.
Mm. Oh, yeah, okay. Yeah. Okay. Okay. Did you get it? Okay. I think most of you, almost half of you, get the correct answer. So to think this type of questions, you get first the information of your fxdx, okay? From 0 to 2, integration fxdx is equal 6. Then if you have this, and you see sine and cosine, probably you can do some substitution here, right? To cancel the cosine. So if you're using u is equal to sine, we'll have du and become 2 cosine theta and d theta. Okay. And when x is 0, u is 0. When x is pi over 2, u will be 2. So the whole integration becomes this, and f u and then du, okay, and half, right? Because it's 2. Then because you know the fx dx, the same integration is 6, then this should be 3. Okay. Okay. Before that, I want to check. Let me check this one. Uh, do you have other answers? Same. Mm-hmm. Same. Okay, let me check. Okay. Okay. Let me give you another one, and then I will give you the midterm. So let me write this. Okay. The question is find f of x if functions is continuous for all x. Okay. So the integrations 1 to x f d dt, x minus 1 e to the 2x, 1 to the x integrations e minus 1 should be, oh, not minus 1, sorry, should be minus x. Okay. You did e to the, okay, okay. I think, yeah. Could be, mhm. Yeah, it should be, I think this is negative x, I think. Yeah. Yeah, I think, yeah, I corrected the questions. I think the book, typo in the textbook. you think this is too difficult? Do you think? This X. Sorry. I can't. Sorry. Wrong. Yeah. I still don't understand. Remember, this is the last Tuesday I gave this integration with FTDT. But yesterday I proved relation between integral and derivative. Gimana? Susah? Oh gitu? Saya kemarin kasih bentuk yang gini kan? Udah, ini udah pernah saya kasih kemarin hari Selasa.
Apa ya? Kata yang beda sama yang nomor 3 tadi. Kalau sampai sini aja nggak apa.
Apa?
Oh.
Any idea? It's using the fundamental theory of calculus.
Is it 2 equal?
I think no. Okay, so these questions these questions we can solve it using fundamental theory of calculus. Okay. And what is this? Okay, that's the question. Okay. So remember that last Tuesday I'm writing this. Okay. Remember this? Okay. This is the one you need to remember. Okay. The proofing, maybe you can just know the logic reason, not memorize everything. That's fine. But at least these key points you need to remember. Okay. This is the fundamental theory of calculus. The connections between derivative and integrations. Okay. To prove that when you have the functions, you can derive, and when you integrate, you are back to the original equations. And precisely because a is constant, okay, any constant, any number, and precisely what we have here is the same as in the fundamental theory of calculus. You have integrations, 1 to the x, f dt, and the other one you have also similar. So what will you do is, if you differentiate left and right, the left part become fx, right? And we can differentiate this, and this become this part. So right, differentiate both sides. And this one become the product rule. So e to the 2x plus 2 e to x minus 1 plus e minus x fx. And then e to the x is 1 plus 2x minus 2. And let me move this to here. Fx is 1 minus e to the minus x. So fx is e to the 2x minus 1, 1 minus e to the minus x. Oh, by the way, the questions actually, it would be better if this come t. There's typo in the real question, so I need to correct it. Okay, and that's the fundamental theory of calculus. Okay, I will upload the notes, the examples later on the Moodle. Now already 2:40. Let me give you your midterm. Okay, someone can help me? Maybe from global engineering and maybe from, yeah, can you help me? Or maybe Jack, you can help me to look at I think this year's right. And let me separate the international one. Okay. Can you check it? And can you put the international one here, the international student, and you can take your department. I think GDP. Okay. Can you check? GDP. Okay. Can you help me? Okay.
先把我们班的挑出来。全球都给你。 So mine's the last time.
Step three. Oh yeah. Uh, hmm, bentar, saya belum tulis nilainya bentar. Hmm. Can you check here? No? Eh, 50. Do you know this? Not
Oh
here.
yeah.
Oh, oh. Can I ask you to keep these
Okay.
three?
Yeah, I'm
Okay. Which is duck and tin.
I will give it to
Good.
you.
Okay. Okay. Um, you can check the answers. Okay. Check the answers. Whenever you find any mistake, maybe miscalculations, please come to me. Okay. Please always check your exam. Calculate the answers. Okay. Okay. For the I have in my midterm and final, or maybe in my this midterm, I prepared some gift for the best two students. Okay. So I think check right, and they both get 100. Okay. Gift for you. Okay. They they both get more than 100. 101 and 105. Perfect. Okay. Okay, the average score, the average uh, midterm, okay, average from midterm is okay 63.46. Yeah, I think uh, from the last quizzes is higher. Last quiz we have uh, 50, around 50, and now 63. So again, there's two um, two ways how to get the 63. Either most of you get higher, or a few are really really high and a few really really low. Okay, so oh, by the way, the midterm is 20%. So midterm 20%, final 30. Okay, final 30%. So you can um, prepare how much you need to pass the course. The quiz, because we will have four. Okay, so quiz 1, 2, 3, 4. Um, they need to be 25. So I divide this become 6.25. Okay, at least this 20, 30, 25. Also, the TA. The TA is 20%. 20%. Have you already take some exam from your TA or no? Or homework? No? Huh? Homework? Okay. Sometimes they can prepare also like a mini quiz in your TA. Okay. Okay. Any questions? Any questions? And also, I think I've read some of your comments. I think that's quite good suggestions. Um, maybe to slow and maybe make some signs, notions for you to write and think, right? Also, I think some international students, uh, because this class is actually new. I mean, last year or last 2 years, you have your own class with the other professors and yeah, using Chinese. But this class is kind of new. We mix the local Taiwanese students with the international students. So I think uh, it's not only, uh, I know some Taiwanese, you get the really good basic from your high school, and maybe um, most of you have a good concept, and maybe the international student have different curriculum. I think, okay, I think that's still okay. That's still okay. And if you want to, I read several comments and from the international students that you want to separate, become only international. I think that's less challenging. You know, uh, if you keep doing that, okay, if you keep doing that, when you are in the real situation after you graduate, you will you will lose your competitiveness. Okay, so this is a good way to learn actually. Okay, and to see how can you overcome the challenge. Okay? And remember, you are not high school anymore. You are not high school students anymore. You need to think more independent. Okay? How you learn, how you study, okay? How you make friends. Okay? And please think this carefully, seriously. Okay? If you think that you need, like, you have a really gap, okay, between you and the courses, okay, for all of you. If you think there's still a gap, okay, then you need to overcome that gap. Maybe you need to change your style. Maybe you need to change your how you learn, okay, how to study. Um, you need to find it by yourself, okay. I can give you more and more like practice, like you're suggesting, practice examples. Okay, I will do that. So I will focus on giving notes for examples and then prepare specific solutions so you can review it. Okay, but again, in the exam, I will give you uh, the questions that it's not actually really long to write, but it's maybe takes time to think. Okay, and if you think correctly, you can find a way easily. Okay, and the quizzes and the midterm, I think is a good way to learn and how to prepare step by step your life actually. Because when you are dealing with these situations in maybe in industry, in the real world, okay, it's not as simple as make the correct answer. There's other factors. Okay, it's not only getting the good grade, passing the course. Maybe you can pass the course. Maybe you can get easy like high score, but it's not also make you um, survive later in the real world. Okay, there's another factor that uh, you need to also think. Okay, and I think one of the factor is how you adapt. Okay, how you adapt to your environment. If you adapt easily, if you adapt with more awareness, okay, you aware of your surroundings, I think you can survive. Okay, for your work, or maybe you want to go for master. I think you can survive if you can adapt to your environment. You see, maybe in the environment, you see, okay, you see a competition, you see how to think creatively. Okay, if you can adapt to that kind of environment, I think you will be survive. Okay, I think you will survive. Okay, so if you still maybe having exam and then you get low score, low score, low score. Um, uh, I don't judge you by your score, okay? Because I know some of you need time to learn, okay? So make up the time, okay? Uh, I cannot guarantee that all of you are going to pass the course, okay? But I will see based on uh, our class, okay, performance, okay? And I will also think some of you who study hard, hardworking, active in class, I will also think that, okay? Like I'm giving some special point and something like that. But of course, it's the percentage is not that big. But if you're hardworking and you keep doing very well, I will see also the progress. Okay, when you came to the class first time, having the first quiz, second quiz, I will see the progress. Whether you are really working and really study. Okay, and again, I'm not forcing you to like pressure, study hard work. You have your own choices. Okay, you need to also take care of your body. Okay? I think also need to think is I think in recent weeks, I think there are some students who suicide, right? Suicide, right? I think five. 6, 3. I think more 3, 5, right? And Taita, right? And Changkong, right? Changkong, Tainan. Yeah. And please don't be take this course like really pressurized and really really make you feel uncomfortable. But if you need, like, for example, some of the students sometimes they message me, or they uh, through Moodle they message me, or they send me an email, like asking some questions related to course, and I will answer them. Usually I will answer them, asking. But if you are asking what the exam looks like, I will not answer. I will just give you, okay. Like, I think some of you are asking if whether they are graphing in the exam or not. I will just say, okay, at least you know how to sketch the graph. I just answer like that, because it's not really a good way to learn if you know the exam looks like. Okay. If you ask about the concept, how to solve several problems, I will answer. Some students, I think in other class, he asked specific questions, and I gave the answers. My notes I gave how to solve. So if you have questions like that, don't bother to ask me. I think some of you asking me, and then if it is too complicated, I will just send some uh, clue to solve by yourself. So if I'm giving you too much, then it's also not good for you. Okay. So if you have like questions, you can come to me and we can have discussion, or you can just send me an email and I will just answer you through email. Okay. Okay. So is there any mistake in your calculations in the midterm? Please come to me. Okay.